In this video, I'm going to show you how you can make this waypoint system. And this is going to be flexible that you can add on to it and expand to make it a bit more advanced as you want to add features after. So we're going to take a player or just a general object we want to follow a path. And then we're going to create all of these waypoints, draw the gizmos, and draw lines connecting the path. And then we're going to make the object follow that path. After we create the system in an empty scene with just some prototype assets, I'm going to show you how this system is modular and you can just click and drag it into any project you want, like this demo scene I have here of a car racing game. Thanks for watching. If you like these videos, please click like and subscribe. It'll help me out a lot, and let's jump right into this. So the first thing I'm going to do is create a 3D object in a cube. This is just going to simulate a player. I'm going to reset its position here. And I'm just going to create a quick material for it. I'm just going to call this blue material. Drag that on. We'll give it a bit of a blue color here. I'm just going to rename it player. This can be anything. A player, an NPC, just a random object that's going to move around. So in this case, I'm just going to call him player just for the sake of it. I'm going to create another 3D object here, and I'm going to make a plane. This is just going to be the ground. Reset its transform position here again. I'm going to move the Y down negative 0.5. That way it's right on the bottom of our cube. And I'll just scale it to something maybe like 20 by 20. Okay, I'm just going to give it a darker color, so I'll make a gray material. Drag this on. Set it to like a dark gray. Yeah, something like that's good enough. And then I'm just going to make a little square inside of this one just to kind of show the direction it's pointing. So I'm going to create a 3D object, a cube. Scale this down a bunch, maybe like 0.25. And now if I move it out, we can stick it out here. I'm just going to make another material for it. I'll just call it red material. Okay, so there, that faces forward on the Z direction. Now the next thing I'm going to do is make an object to hold our waypoints. So I'm going to create an empty object. If you're not familiar with the shortcut to create a new empty object here, you can just do Control-Shift-N. Now I'm just going to name this Waypoints. And I'll reset its transform position as well. I'm just going to add a script to it. I'm going to call it Waypoints. And under Waypoints, I'm going to make a child object here, just an empty game object. And another keyboard shortcut, if you're not familiar with it, to make a child empty object, you can hold Alt-Shift-N. I'm just going to call this Waypoint. Okay, so that's an empty one. It's at 000 for position. And this is what we're going to use for a waypoint. And I'm just going to move this randomly somewhere off so it's off the player. It doesn't matter where. Now let's go into our waypoint script. And I don't need a starter and update in here. What I'm going to use is a method that you may or may not be familiar with it called onDrawGizmos. And this is a method that's called in the editor so that we can actually draw something in the scene view. And I'll demonstrate that in a minute here. Let's just draw a sphere for all of our waypoints first before we do anything. So I'm going to do a for each loop. I'm just going to do transform T in transform. So we want to loop through all of the transforms that are part of waypoints. And this means it's going to get all of the transforms that are children. And now in here, we can use a command called Gizmos. And then we can pick a color. So I'm going to do color.blue. And then we can do gizmos.drawWireSphere. And this is going to draw a sphere in the scene. And by wire sphere, it means it's a see-through sphere. It's just a wire frame. You could draw a solid one if you wanted as well. Now we need to pass in a center position and then a radius. So I just want to use t.position and then radius, we'll just do 1 for now. What we're doing here is this for each loop. It's going to take every transform that's a child of our current waypoint system. So if we look back here, what it's going to do is get all of the children transforms under waypoints. So currently we only have one here, but you can notice it actually drew this blue sphere. If I select this waypoint, I can drag it around, and anywhere we put it in the scene view, it's going to show this sphere. But if we look at the game view, we'll just set the camera. Let's select our camera. And another shortcut, if you're not familiar with this one, you can align the camera with the current view that we're looking at by hitting Control, Shift, and F. And now the camera is set here. So if we look in the game view, we don't see that gizmo. And that's exactly what a gizmo is. You've seen them already. Like if we select the cube here, this X, Y, and Z little gizmo thing here, this is a gizmo. Exact same thing. We can just make our own. Let's go back to our script here. And we're going to want to make a system that can draw a line between multiple waypoints now. Let's actually go here and let's duplicate this a few times. So I'm going to Control D to duplicate the waypoint. I'll drag this one over here, Control D again, drag this somewhere over here, maybe like there, Control D one more. So there, we got 4 waypoints. They're kind of scattered around. But just looking at this here, we don't know the order the player is going to take. If we look here, it looks like they're in order, but we could scatter these in some weird roundabout way. Put them like this. You wouldn't really know the order just by looking at them. So we need to make something that displays that for us. Now we can see each gizmo, but we don't see how they're connected. So let's do another. After that loop, I'm going to do gizmos again, .color. I'm going to set this one to be color.red. And now anything we do with gizmos after this is going to be red until we tell it something else. Let's make a for loop. I'm going to do int I equals 0. And then we want to do I is less than transform.childcount. And then we also need to subtract 1 on this, and I'll show you why in a minute here. And then we need to increment I by 1. All right, and in here, what we need to do is let's do gizmos, and then another method on here is called draw line. And this will just draw a line between 2 points. So we need to give it the first point. The first one we want here is going to be our first waypoint. So I want to do transform.getchild, which is going to get a child in the hierarchy. And they're ordered by number. So let's just go back to the hierarchy for a second here. If we look at them, this is the first waypoint child under waypoints. So this is going to be child 0. And then the next one's going to be child 1. So it just works in sequential number. And then if you move them here, so if we moved waypoint 2 to be this one, now this is going to be child 1. So the name does not matter at all. It's the position and the order that they're listed as here. Now for the first position we want to draw from, we want to use I as the child index, which is our loop counter. So the first time it runs, this is going to be child 0. We want to use .position. And then for the second point, we're going to do the same thing, but we want to use transform.getchild. And we want to use I plus 1 to get the next child. .position. Now if we go and look, we see it drew a line between all of these. And to demonstrate why we wanted to use -1, if we didn't have this in, what's going to happen is when we get to the last count, which is the last child, it's going to try to draw a line from the last child to the next child, which doesn't exist. And that's going to give us this error here that transform child is out of bounds because it doesn't exist. So we want to stop 1 time before the last child. And as you notice in the game, from our last child, it doesn't connect back to the first one. So we want to do that now. So right after this loop, let's just do gizmos.drawLine. And we can do transform.getChild. And for the child, what we want to do is use transform.childCount, which is going to be how many children there are, -1. And then we want to get its position. And the reason we're using -1 here is just the simple math on it. So if we look here, if we use child count, we have 1, 2, 3, 4 children here. But remember, they start at 0. So this is child 0, child 1, child 2, child 3. If we want the last child, we actually have to remove 1 because this is child 3, not child 4. It would only work if we started this one at 1 instead of 0. So just something to always be aware of because that can cause a lot of errors when you're starting out. Okay, and then the next position we want to make it to is transform.getchild and then 0 because we want to go to the first child. All right, let's go take a look. This should draw a loop between all of our objects here. And now you can see in the editor, if you drag it around, it updates real time. You don't have to compile or do anything else because onDraw Gizmos is running all the time in the scene, but it doesn't run when you're in the game view. And I just want to demonstrate that because if you look at this, you might think this is going to waste a lot of resources when your game's running. Because every frame we're doing an update where we search through all the transforms, we draw these spheres, and you would think if we have a whole pile of these, we're going to slow down our game. I just want to show a demonstration in Draw Gizmos here. I'm going to do debug.log, and I'm just going to put test. We don't need to say anything. So now if we go back to our game, let's refresh this. Okay, so notice test is running. It's kind of running randomly. It doesn't run every frame, but it is running. And if I start moving one around, notice as I'm moving, it will update every single frame. So it looks like it's doing a lot of work here, and it's just updating on changes. But if we go to the game tab, I'll just clear it to demonstrate. Notice that code is not running at all. And this is with the game off. And the same thing happens if we run it. So if we run our game, even though nothing's going to move right now, let's just take this off maximize. So if I run it right now, nothing's actually moving, but the game is running. If I go to the scene view, now you see it's updating constantly. But if we go back to the game view, it's not updating. So that's just something to make sure you're aware of. onDraw Gizmos is only going to run when you're on the scene view editing your game. So this isn't going to cause impact when the player is actually playing the game. This is just to help us visualize and see what we're creating. One thing we can also add in here is I'm going to make a serialized field, private float. I'm just going to call this waypoint size. I'll set this to be 1. And I'm actually going to add in above it, I'm going to add range. And you can set this to be whatever you want. I'm going to set this from 0 to maybe 2. Now, if you're not familiar with range, it's an attribute you can add for a variable here. And it's going to make a slider bar between these two values. Let's take our waypoint size variable and replace it here in the draw wire sphere. Now, if we go back to our scene view, we have our waypoint system, and we can actually change the size of these. So you can make them be as big or small as you want. And if you don't like the wireframe one, you can just change this to be just draw sphere. So if you save that and we go back and look, now you can notice it's a solid one. But when your object's moving through, you're going to see it's going to go into the sphere, and sometimes it gets visually hard to see. So I'm going to leave them as wire sphere. But that's completely your preference. Okay, so we have that set up now. When the player or the object's moving, trying to use these waypoints, we need a way for it to actually get what waypoint it should be moving to. So I'm going to make a public method here, and it's going to return a transform. I'm just going to call it getNextWaypoint. Okay, and what we're going to do is we're going to pass in a transform, and I'm just going to call it current waypoint. And I'll explain this in a minute here once we actually create it. Now, for now, I'm just going to do return null just so we get rid of that error so we don't have any errors. Let's go back to our game. I'm going to go to our player, and I'm going to add a script. I'm just going to call this waypoint mover. So you can name this whatever you want, or you could even do this right inside of something like a player script or a player controller. But I like to keep them separate so that you can add this to any object. So you could add the same one to a player, to an NPC, to just a random rock that you want to roll around your scene. That way it's not locked into any other component. You can just make it separate on its own. First thing we're going to need to do is get a reference to the waypoint system. So I'm going to make a private, I'm going to call it Waypoints, and let's just call it Waypoints. Okay, could make a note here. Stores a reference to the waypoint system this object will use. Or just something there, just so you know what it is. Okay, make another serialized field. I'm just going to make a private float move speed. I'll set this to maybe 5 by default. This is just going to be how fast the object moves. And then I just also need a private transform. And this is going to be the current waypoint we're moving to. Okay, so something like that. So that's our variable set up. That should be all we actually need. The first thing I wanted to do is, if we go and look at our game here, in this example here, the player object's not actually at the first waypoint, or any waypoint for that matter. What I want mine to do, and this is optional, you don't have to do this if you don't want, but when we start our game, if I had the player over here and say this was the first waypoint, I don't want them to start randomly moving to that waypoint. I want them to be there. So I'm going to do that in my code here. The first thing I'm going to do is make the player move to the first waypoint. So in start, I'll do something like set initial position to the first waypoint. Okay, and now we need to get that. So current waypoint, we need to call something to actually get this. And we did start our getNextWaypoint method. So I can call getNextWaypoint. Or sorry, we need to use our waypoints script up here, the reference. So Waypoints.getNextWaypoint. And I need to pass in a transform. And you're going to see why we decided to go with transform right away here. But when we're getting the next waypoint, what we want to do is pass in the current waypoint that this player has. So if we just pass in current waypoint, this is going to tell our getNextWaypoint method what waypoint we're using currently. And if we didn't do this, then we would have to do some tracking inside waypoints here. So for example, we would make a variable and it would be, you know, current waypoint or waypoint index, something like that. And it would track which waypoint the player is moving to, and we would update it each time. But the problem with that is you would only be able to use these waypoint systems with one object. Because if you were using it with multiple different players trying to move on this waypoint system, they would all think they're using that same waypoint number that's in here. By doing it this way, every time we need a new waypoint, we can just say, hey, waypoints, this is where I currently am. What's the next waypoint to go to? And then that way we can use it as many times as we want. So let's go back in here, and now we have to actually do something here. So I'm going to remove this line. And with the current setup that we have here, what's happening is in start, we're calling waypoints.getNextWaypoint, passing in this current waypoint, which currently has nothing in it. That means it's currently null. So if we go into waypoints, the first check we can do here is let's check if current waypoint equals null. Then what we want to do is return transform.getchild 0, which is our first waypoint. Basically what we're saying here is if something calls this method and it passes in a waypoint that doesn't exist, which means it's null, then tell it go to the first waypoint. Now we can test this out. We just need to do, I'll just do a return null here just to get rid of that error, because otherwise it'll say if waypoint's not null, it's not returning anything. So we always need to return something out of this method. So this is currently only going to work for this one case. But if we look at this here, this should work now the first time. So what we can do is let's set our players transform.position equal to current waypoint.position. Let's go run the game. Oh, and we're getting an error. That's because on player, we didn't drag in our waypoints yet. So we got to drag in the reference to the waypoints. Now let's run it. Okay, and if we look at our scene, now our player's right on position 1. And if we stop, he goes back. Okay, so that's perfect. Don't worry about this error. That's because of what we're doing right now. That's just for testing. Okay, so that works with the first position. Now we need to do it again. So what if we pass in something that's not null? So we need to do another if statement here, and we need to do if current waypoint. And now we need to check which waypoint this is in all of our waypoints. The way that we can actually do this to check what child this current waypoint is very similar to how we used getChild with an index. We can actually use current waypoint, which is a transform, and transform has a method on it called getSiblingindex. So if we do this, what this is going to do is just like we used getChild to get the child at 0 position, this is going to get the actual index of that. And why it's called getSiblingindex is when we look at it here, say if we passed in this waypoint as the current waypoint, all of its siblings are these ones, all of the ones under the same parent. So what it's going to do is it's going to get the index under this parent, which in this case is going to be 0 and then 1. So it's going to have a sibling index of 1. This one will have 2. So it's the exact same thing as getChild, except the reverse. In this case, we know the object or the transform, but we don't know its position. So now using this is going to give us the actual sibling index or the child index, if you want to look at it that way. And then we can make sure it's smaller than transform.childcount minus 1. And again, the minus 1 is because we don't start at 1, we start at 0. Now, if this is true, what we want to do is we're going to return transform.getchild. And the child we want to return is current waypoint.getSiblingindex plus 1. So basically we're saying if this sibling is anything except for the last sibling, that's why we're adding the minus 1, then just add 1 and that's the next one. So we need one more thing here. We need to do else. And what this is going to do is if this is the last sibling, then we need to return the first one. So we just return 0 again. So to give a bit more of a visual, if we pass in any of these waypoints, we're checking with the -1 to make sure it's not the last one. So if we pass in this one, we're going to return this as the next one. If we pass in this one, we're going to return this as the next. But if we pass in this one, we know it's the last one. So then we return the first one. So that means the player or whatever object we're moving is going to loop through each one. It won't try to go to a next one that doesn't exist. Now we can start testing this out. So let's go back into our mover. So now we added the first waypoint and we moved our player there. So now let's set the next waypoint target. So this is one we're actually going to move towards. So let's do current waypoint. Actually, we can just copy this whole line because we're doing the same thing. Okay, so we have that, but we don't want to move him there yet because he'll instantly just snap there and we won't even see him go to the first one. So that's where we got to do it in update here. So all we have to do here is let's do transform.position equals, and we'll just do vector3.moveTowards to keep moving them there. And we just need to pass in our current position and then our target position. So we'll do transform.position, which is where we currently are. And then we're just moving to current waypoint.position. And now for how much we move, we just want to use move speed times time.delta time. Okay, and that's it for moving. But this is only going to move us to 1. So let's test this out, make sure it works. Okay, so we move to our first one and then we stop because we didn't tell him to do anything there. But that's working, so now we can move on to the next one. And to do this, we just need to do an if statement, and we can do vector3.distance, and we need to pass in our 2 positions. So our current position and then our current waypoint.position. And we just need to make sure it's less than a certain amount. So we should probably make this into a variable. So let's do, maybe I'll call it distance threshold. So let's go create this. We'll make it a serialized field that we can change in the inspector if we want. So, whoops, that needs to be float. I'll try something like 0.1. That should be good enough. Okay, so if these two positions are closer than this, then what we need to do is current waypoint. We need to get it at the next one. Now let's go and test this, and this should be working. Okay, so we move to the first one, we move to the next. One more. Back, and we should loop. All right. So that's basically a simple waypoint system. You notice our guy is not rotating though. So a very quick solution to that we could do in here after we get our first waypoint that we're moving to. We could do transform.look_at and then just tell them to look at the current waypoint. We don't even have to say position because look at can take in a transform. Okay, and then let's just copy that and paste that in here. So every time we get a new waypoint, we're just going to look at it. So now if we run it, he should face the waypoint. But this is going to be very snappy movement, so he instantly moves. There's no smooth transition. Okay, so you see that's working. So that's our basic waypoint system. There is a lot that you can add onto this though. I tried to keep it very basic, so we're not using anything fancy in here. But you could start adding things to liven this up and make it more of a utility to use. So for example, in the waypoints, you could make it so that you can pass in on this method to get the next waypoint. You could also pass in a Boolean if you're moving forward or not. If you're moving forward, return this, but if you're not moving forward, which would be reverse, you would return the previous waypoint. And then another thing you could do in here is you could disable it from looping. Instead of making it loop and go in a big circle, you could make it have an end at the last waypoint, so it wouldn't draw this line and it would just go from there, and then you could make it kind of ping pong and go in reverse. So there's a lot of versatility that you can add to this. As well, for the rotation, to make it more smooth on the waypoint mover, you could do something in here where once you hit this position and you get a new waypoint, you could run a coroutine and tell it not to actually start moving yet and do a slow rotation to that target. And then once you're rotating towards it, then you could start moving. So something like that, just adding little features here and there. What I'd recommend is doing something like this and exporting the package. So you could save it as your own custom package. And then from there, when you work on new projects, bring it in. And as you start adding new features, just keep exporting the newest version. And to demonstrate how handy that can be, I'm actually just going to show you. So this is our simple little kind of prototype scene here. But I also have this demo scene that I set up here. This is just some Cinti assets that I own. And what I did here is I just put this car at this spot of this track here. And there's currently nothing on the car at all. So to use our waypoint system, what we can actually do is let's just create an empty object here. So Control-Shift-N. I'm just going to reset its transform. I'll call this car waypoints. Now I'll create another empty object here. I'm just going to move it to kind of the first position. I can put it in place and now drag it in as a child. So then it's right here. So I'll call this waypoint. Now all we have to do is on the car waypoints, let's add our waypoint script. Okay, so now we see our waypoint. Let's make it a little bit smaller for the gizmo. And then on the car, we add our waypoint mover. Drag in our waypoint system. Okay, and now on waypoints, Control D, let's make a waypoint here. Actually, maybe I'll move the first one to where the car is. This one over here. Make another one over here. Another one over here. And something like that. This one you're going to see them go through the wall because this isn't the whole track. But I don't want to go and make the whole circuit. But now notice they are raised up in the air. So we just got to drop it down to... I'm going to select all of them. Set the position to 0. Okay, and we weren't actually on the ground plane. So got to move these again. That's my bad there. Okay, so there's that one. We'll do one here. Okay, so we'll treat it like this is the end of the track. So ignore this part. But if you went through and you did the whole track with all the waypoints, he would go the entire path. So now if we run this, now we can see our car going. And you can see, like I mentioned, the rotation just snaps. But if you were to actually smooth that out, you can make this car go through an entire waypoint system here. And then you could start adding things. You could even add in little features that make it drift when it's turning. Things like that, all in your waypoint system. So there you go. That's a basic waypoint system. I hope you like that one. If you do want me to cover more of those topics I mentioned, like other ways we can improve on this, let me know and I can always make a video and we can start making it more complex. I wanted to keep this one pretty simple so it's still fairly beginner friendly. But thanks for watching and I will see you in the next video.